Something weird is going to happen now. We are recording. What was my joke of the day? Kid said he liked it. I'm trying to think. I forgot already. Oh well. That's why we got to write them down. Okay, so today we're going to learn about inverse trig functions, and these are you guys. You look very wholesome and happy and all that kind of stuff, but that's a little bit too wholesome and happy for me. So I changed the picture. Okay, hold on a second. I changed the picture to this one. Those guys are. So that's kind of creepy, huh? Those are Beavis and Butthead statues. Okay, that's what I got. So anyways, so this is called inverse trig functions, and what you should learn. You don't have to write this down. So how to evaluate and graph inverse trig functions, evaluate and graph other inverse trig functions, and evaluate compositions of trig functions. We're not going to, so today we're just going to talk about, the first thing, which is evaluating graphing inverse sine functions, and the other, we're just going to do these two, and we're going to wait until Monday to do this one. And composite functions. These are kind of fun. They're kind of interesting. I like doing them. Inverse sine function. Okay. So what an inverse sine function? Whereas a sine function, you put in an angle and you get at a value for the sine. The inverse sine function, you put in a value for the sine and you get at an angle. So for example, if I were to put in inverse sine of negative, let's just do a positive 1/2. Okay, that means what is the angle whose sine is positive 1/2? This is where you kind of have to know your unit circle pretty well. Anyone know what that is? Anyone can tell me what that is? Colton? Yeah.
Or sine is 1/2. That is
30 degrees, okay? Or pi over 6 radians, okay? So that's going to be equal to pi over 6 or 30 degrees. But the problem with that is that on the unit circle, there's two places, right, where sine is equal to 1/2. One is over here, right? And sine is always also positive over here. So in order for a function to be a function, when I plug something in, I can only get out one answer, right? And so what they do is they restrict the sine function's domain, okay, so that it is 1-to-1, okay? So they only take the sine function from, this would be negative pi over 2 to pi over 2. If I look at the sine function between negative pi over 2 to pi over 2, I get all the values that sine can give you back, right? From -1, because sine is -1 at negative pi over 2, to positive 1 when sine is pi over 2. So they restrict the domain of the original function so that the range of the inverse function only has one answer. You get it? Okay? And we'll talk, and so when I graph it, it's a reflection over the line y equals x. We'll look at a minute at what it looks like, okay? But we'll kind of go through some problems, okay? And, that's what they talked about, okay? So you could write down some of this stuff. So I should, every time I write something, I should put something on here so that it records this page so people can see it, okay? So, however, when you restrict the domain to the interval, x goes from negative pi over 2 to pi over 2, corresponding to the black portion of the graph on the last page, the following properties hold. On the interval from negative pi over 2 to pi over 2, the function y equals sine of x is increasing, okay? So if I look at it, it's like from the bottom of one side to the top of the other side. It's doing this, and you get all the values that sine takes out. Okay? So on the interval, it's 1 to 1. That's just kind of what I talked about. Okay? And now, because it's 1 to 1, then I can find an inverse. Okay? So between negative pi over 2 and pi over 2, y equals sine of x has a unique inverse called the inverse sine function. It is denoted by y equals arc sine of x or y equals inverse sine of x. So I will use these interchangeably. Whoops. I will use these words interchangeably, arc sine and inverse sine. They mean the same thing. Okay? And arc sine, and I didn't know this, I just found this out. I've been teaching this for 20 some odd years, but arc sine is called arc sine because you get back an angle, and the angle is defined by the arc that it carves out, right? So that's why it's called an arc sine, because you're finding an angle whose arc is given by some trig function, okay? So it comes from the association of the central angle with it. You don't have to know that, but it comes from the idea that you're looking for an angle that's determined by this arc over here, okay? So arc sine or inverse sine. Easy enough? So here's some stuff that you should know. I wouldn't write this down yet because I have a whole, the last slide has a summary of inverse sine, inverse cosine, inverse tangent. Okay, so don't worry about this yet. Okay, but the inverse sine is defined by, going back. Okay, the inverse sine is defined by y equals arc sine of x, if and only if sine of y equals x, where x goes from negative 1 to 1 and y goes from negative pi over 2 to pi over 2. The domain of arc sine is negative 1 to 1, and the range is negative pi over 2 to pi over 2. So this is a function that ends, okay? It doesn't go on forever like sine. So, and we'll talk about what the graph looks like in a minute. But then you have problems to do based on this idea. So arc sine of negative 1/2. So what that's saying is where between negative pi over 2 and pi over 2 is sine equal to negative 1/2. Who can tell me where that is in terms of radians? Where would that be? We almost answered in the first little question that we have to go backwards instead of forward. Where's sine negative 1/2? Sam, you're not playing with your phone down there, are you? No? Okay. Where is sine negative 1/2? Not 150 degrees, it'd be positive 1/2. Okay? So it'd be here, right? Because sine is negative there, and sine is negative here as well. However, this is only, arc sine is only defined from this area to this area. So the only one that I use is over here, because I can only have one answer when I plug in a value to a function. All right? So out of those two angles, I'm going to use this angle right here. And what do I call that angle? Negative something. Negative 30 degrees or negative pi over 6. Okay? Negative 30 degrees or negative pi over 6 radians. Okay? Yes, ma'am.
So it only works in quadrant 1 and 4?
Only in quadrant 1 and 4, but when you got to be careful because you can't get to quadrant 4 going this way. Emma, you can't go this way, you have to look backwards. Okay? So because when you graph it, you're only looking from here to here or something. You're not going beyond here to look for the value, you see?
Okay.
So then where would sine be square root of 3 over 2? Can you tell me?
60.
60 degrees or pi over 3 radians. The only place where sine is positive root of 3 over 2 in two places. But I'm going to choose this one because this is the only one that's between pi over 2 and pi over 2 and negative pi over 2. So that's equal to 60 degrees, which is equal to pi over 3 radians. Oh, doesn't this screen look nice? So nice and bright. Yeah. All right. How about this answer? Where is sine equal to 2? Who's smart kid?
0.
Where is sine equal to 2? Oh. Yes, Trent?
When the cosecant is 30 degrees or something.
Kind of the right idea, but sine is never equal to 2. Okay? This is saying what is the angle whose sine is 2? Well, when you're when you're looking at sine, right? Sine is the opposite side over the hypotenuse side, right? The opposite side is never going to be bigger than the hypotenuse side, so at sine it only goes between -1 and +1, right? So if I try to take an inverse sine of 2 and I plug it into my calculator wherever I try to do it, I'm going to get an error, okay? Error. And remember that the domain of inverse sine, that domain of inverse sine of x only goes from -1 up to +1, okay? So you can't plug in a number that's less than 1, -1, or bigger than +1. Yes, sir.
So we're only dealing with the unit circle for this lesson, right?
Well, yeah, it's on the inner circle, but no matter where you are,
Yeah.
the opposite side is never going to be bigger than the hypotenuse side. And I did notice something on your quiz. A bunch of you made this mistake, okay? We had a non-unit circle where this was like 13 and this was like -12 or something like that. I don't remember exactly. And this was like 5 over here. You have to do Pythagorean theorem. The sine of this angle is not 5. Sine of this angle is 5 over 13. Sine can never be bigger than 1. It's 5 if this side is 1, right? If the hypotenuse is 1, it's 5, but not if it's not, right? Because sine can never be bigger than 1. It's always a number less than 1, between -1 and 1. So a lot of you made that mistake. Don't worry. If you blew the quiz, you'll have, this is just their answers, okay? Sketch a graph of arc sine by hand. I'm just going to show you what it looks like, where it comes from, okay? So, for this one, sketch the graph of arc sine by hand. What they do, so notice that these are the values down here, okay? These are the values that you would normally plug in for x into y equals sine of x, right? But in an inverse trig function, the x and the y's switch places, right? So x is the sine of y, which means if I take the sine of this, I get -1. If I take the sine of this, I get -√2 over 2, and so on and so forth. Sine of pi over 2 is 1, but when I plug into the inverse function, which is inverse sine of x, okay? If I plug in 1 into inverse sine of x, I'm going to get out pi over 2, okay? If I plug in √2 over 2 into inverse sine of x, I'm going to get out pi over 4. Yes? No? So when I graph this, okay, what I get is this kind of funky looking graph, okay? You should know the general shape of this graph. Okay? So notice the difference. This is not part of the sine graph. This is what I would have if I took, oh, that's bad. If I took the line, okay, if I took the line y equals x, here's y equals x, perfect, okay? And I flipped the sine graph over that line. This is kind of weird because the scale on these axes is way different than the scale on this axis. Here I have -1s up to 1, and here I have pi's and stuff. So it won't reflect nicely over this line, but if you made the scales the same, it would reflect nicely over that line. But this is what the graph of y equals arc sine of x. So if I plug in if I plug in, what would this be right here? This point is 1/2. If I plug in 1/2, I'm going to get out pi over 6 right here. So this right here corresponds to the point 1/2. Plug in 1/2 for x, get out pi over 6 for 1. Plug in root of 2 over 2 for x, get out pi over 4 for y. Plug in negative 1/2, get out negative pi over 6. You guys follow that? Okay, but that's what the sine graph looks like. It stops here. Okay, starts and stops there. The inverse sine graph. Okay, so moving on. What happened? So sine has it. Where other trigonometric functions? Inverse cosine of x. Okay. Inverse cosine of x, we also have to restrict the domain on. Okay. Yes, you could graph these on your calculator because inverse sine, it takes on all the values. So if you think about the unit circle, okay, I mean inverse cosine. Cosine, if I go from, they restrict the domain differently. They go from 0 to pi because from here to here, cosine takes on all the it's positive here and negative here. Okay? So what I do with inverse cosine, my domain is still negative 1 to 1. Okay? But my range is, it's only going to return value, or my range is only going to have values between 0 and pi. Okay? So this is the domain, and this is the range. So when I plug in something into inverse cosine, what would be the inverse cosine of negative square root of 3 over 2? Anyone tell me? Oh, does this write nice? What is the inverse cosine of negative root of 3 over 2? Where is cosine equal to negative square root of 3 over 2? On your unit circle. But for inverse cosine, you don't go this way. Anyway, it'd be positive here. If I want negative 60, cosine is positive. So it's asking, where is cosine? Cosine's negative here, right? And it's negative here, right? So it would be at 5 pi over 6. It'd be over here because you only look in the first quadrant and the second quadrant. Don't worry, there's going to be a little summary page in a minute, okay? That sums this all up, okay? So this is going to be 150 degrees or 5 pi over 6. This is why you really got to know your unit circle. Where's cosine negative root of 3 over 2? Well, it's negative root of 3 over 2 here and here. But the only one I'm interested in is the one in the second quadrant. Yeah. I'll move it on. And you could graph these things much the way you graph sine, right? So you would just use this table right here to graph the inverse cosine. So this is the same as inverse cosine of x, okay? X equals cosine y means the inverse cosine of x equals y, okay? Then, let's see, I think I put the graphs up here. This is what you should probably write down, okay? So this is kind of a summary of all that stuff. I have to escape so I could pause my, oh! Where'd those guys? Those guys were scary. Who are those guys? I'm going to pause. I'm going to undo my, where did it go? Where did it go? It went there. Okay, so I just wanted to point to this table for those of you in the viewing audience. Okay, so we're going to move on to the next. No? You don't have to write, you don't have to color it yellow or anything. You just write it there. Oh, you were coloring it yellow? Sorry. Ready to, don't worry, it sounds kind of overwhelming and tough, but you'll see how it works in a second. Okay, I'm moving on. We could go back. I want to make sure we have time to the next thing. Okay. So going back to my PowerPoint, this is what your three inverse trig. This might, I don't want you to copy this down because that'll take you too long. But the inverse sine function looks like this. It has x values between -1 to 1, and it has y values between -pi/2 to pi/2, if I were to graph it, okay? You could just sketch these real quick, okay? Inverse cosine, its domain also goes from -1 to 1, okay? But it goes from pi at the top to 0 at the bottom, because the cosine of 0 is 1, right? The cosine of pi is -1. So if I'm plugging in x values, it kind of is backwards of what you think it is. But I looked for it between 0 and pi as a y-intercept right here. And the inverse tangent looks kind of like this, and it goes on forever in either direction. Unlike these two, they end at the endpoints. This one goes on forever, okay? Except it never touches pi/2 because tangent is undefined at pi/2, right? You have asymptotes there. So the inverse tangent, the answers can get really, really big, but they can never be, the answers can be close to pi/2, but can never touch them. But the values that you plug in have to go from -infinity, can go from -infinity to +infinity. So this one goes like this forever, okay? Questions? Okay, so now we're going to do some examples.
Can you just hold on 1 second?
Hold on 1 second, yes. I have to pause my cutting edge video. Hold on. Okay, so now, was I paused all that time? Or was I going? I was paused, now I'm going again? Okay, so so this is just how you sketch graphs. I stuck in this slide because you kind of have some homework problems like this. So if I know that so this you just do, we're not going to graph these real in depth, okay? Like we did the sine and cosine and cosecant, just sketches of them are fine. But there is a trick. Inverse tangent from the last slide, it looks something like this, right? Okay, it has asymptotes at pi/2 and -pi/2, and it takes on values forever. So there's a trick to graphing this, okay? Inverse tangent of -x minus 2 is equal to the inverse tangent of -x minus 2. Do you guys understand what I just did? I pulled out a negative out of this parenthesis. This is still equal to this, right? Because if I distribute this negative through, I get -x plus 2. Yes, sir?
Is tangent of -1 even or odd?
Tangent, inverse tangent, you go look, you tell me. Look at the picture. Is it even or odd?
Odd.
It's odd because it's symmetric around the origin, right? I can turn it 180 degrees. So that means that inverse tangent of -x minus 2 is the same as negative inverse tangent of x minus 2. What's the negative going to do to it? What's its negative do to things? It flips it this way, right? What's the 2 do to it? Moves it right, okay? So I'm going to go 2 units right, okay? And then it's going to flip something like, going to look something like this. That's all I'd be looking for. It's just a little sketch like that, okay? To know that it looks like, you get that? How I figure that? But it's tricky because you got to pull out that negative because I don't know what this does all by itself. And this is plus, you would think I'd move it backwards. But when I pull that negative sign outside. So arc cosine, inverse cosine, you have to kind of know what the original graph looks like. which starts at, I always have trouble sketching it, something like that, okay? So is arc cosine odd or even? Is cosine even or odd? Inverse cosine.
Even?
It's actually,
Why is it odd?
it's, it,
I mean, what do you consider the origin, like 0, 0, or the origin of
yeah,
the
so
middle
it would
point?
be even, it's neither, is it? Isn't it? So I think with this one, I think it's gonna, I'm not sure, to tell you the truth, but I think the negative sign is gonna flip it upside down, okay? Because it isn't even or odd, right? It's just, it's obvious by looking at the graph, it's not even or odd. And this 2 is gonna move it right 2. So I'm guessing that it's gonna be 2 down and to the right 2. But I'm not exactly sure. You'd have to play with that on your calculator. Okay? That, well, it's still, anyway. I'm not going to worry. I have to think about this. I'll come back to that one. That was a bad example because I was thinking, oh, this is even, it's just the same as arc cosine of x minus 2. But it's not because inverse cosine is not even. Okay? It's weird, huh? So then we have some problems to do like this. This is what your homework problems, a lot of them are going to look like. And these you should be pretty good at. So let's just go through with these and then we'll be kind of done. Who can tell me what's the arc cosine for a valuable prize? Hey, you can win a valuable prize if you get this right. I'm giving you candy. Okay, go ahead, Colton.
45 degrees.
That's right. You get a valuable prize. There you go. There you go. Hey, you got to raise your hand. Who's got the next one? B. Inverse cosine of -1. Wait, raise your hand. Oh, you were raising your hand. Tenzin. It's pi. Do you guys understand why that's pi? Okay, because that's saying where between 0 and pi is cosine equal to -1. And the answer to that is pi. You get a valuable prize. I have one Starburst left over from, no, I'm just kidding. Okay. Do you want a Tootsie Pop? What color? Brown, green, red? Red. One red. There you go. I'm not giving out bonus points, just Tootsie Pops. Oh! I get to do my rant. It's not really fair that I'm picking on people, so I'm going to use my random number generator to pick on you. Okay? Yeah, that's only fair. Okay, so I'm going to go. You're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You're done. 21, 22, 23, 24. Okay? And here we go. Math. I had to go to math, DRB, random integer. How many numbers did I have? 24. 1, comma 24. If you could tell me the right answer, number 23, who's number 23 to arc tan of 0? So arc tan of 0. In other words, where is tangent 0 between -pi/2 and pi/2? Who's number 23? Elsie. You know the answer? Ah, someone else's turn. Number 22. Samantha. No time to think. You had enough time to think. Number 4. Who's number 4?
pi/2.
No. That's inverse tangent. Tangent is undefined at pi/2, right? Goes to infinity. Okay. Number 13. Who's number 13? This is number 13. Do you remember? Yeah.
11, 12.
I guess you're no.
I'll take 13.
It's either Ian or Sam. I don't know. Sam's got.
Is it 0?
It's 0. Yes. Was that what you were going to say, Sam? You can both have a valuable prize since I'm.
What? He said no. He said yeah.
He said no.
No, he said yes.
He had his hand up. Mr. Wood.
How's it going?
Do you have a joke for us?
Yeah, did you hear about the two antennas that got married?
The two antennas that got married.
The reception was
Yeah.
amazing.
The service wasn't all that great, but the reception was fantastic.
Hey, did you hear about the wedding on the moon? That's the wedding on the moon.
No.
No? Wait. The wedding at the reception was horrible. But, yeah, the wedding on the moon, it was a great wedding, but it really had no atmosphere. Oh, that was the restaurant on the moon. That's right, that's it.
Okay.
Okay. There you go, you guys can fight over those two colors. Okay, next one. Inverse tangent of -1 goes to number 10. Who's number 10? That would be,
I think it's you, because I don't love it.
where is tangent -1 between -pi/2 and pi/2? Connor? Connor, number 2, back Connor. Oh, close. Wait, I gotta pick up, be fair. Number 18. Who's number 18? You guys remember?
If they don't.
You don't know? Aubrey? Wait, what number were you? 13, 14, 15, 16, 17, 18.
No.
No, 17, 18, Trent.
She's
Negative
18.
3 pi 4.
It's not 3pi/4 because inverse tangent only goes from -pi/2 to positive. So you can only look here or here. Okay?
Oh, wait, what?
Wait, number 2. Number 2. Number 9?
Power 4.
No.
No?
-1.
I don't know.
I got it. Number 24.
Oh.
Negative pi 2. 7 pi 4s.
It's not 7/4. Because look,
It's -1.
you can't. Shh, you can't get there. Look, you can't get there by going that way. You have to get there going that way. You want to revise your answer?
Oh,
I do.
-pi/4.
That's
why I
I've
gave
been
him a
saying it for a really long time. I have to get it.
Yeah, I know.
There you go. What?
So close.
I've been saying it for a really long
Okay,
time.
Christian. Okay. You guys can fight over. That's all I got. Hey, it's not time to go yet. So, no, it's not.
2 minutes.
So, no, we don't. No, we don't have 2 minutes. I have the schedule right here, okay? Period 2 gets out at 9:15.
But the walk is far and there's gonna be people there.
That's 10 minutes. No, I'm not letting you out 10 minutes
What
early.
about
5
eight?
minutes.
What about
5
eight?
minutes.
5 minutes.
They're looking for every reason they can to get rid of me, so I don't want to.
I don't think so.
I make way too much money, so for being a school teacher, so I'm not.
It's like Mr. Lynch kids. Oh, wow.
Oh, last thing. I do want to show you these. Okay, so if they say use your calculator to find this, do you guys know how to do that? Okay, you just take your calculator and because I know you like using your calculators, right? So you just take your graphing calculators. You make sure, depending on how the answer is called for, okay, you either on radian mode or degree mode. Let's just say we're in degree mode, just to get more of an idea of what it looks like. So that's where you use the second sign, okay? Second sign of -2 divided by 3, okay? Whoops. -2 divided by 3. Close your parentheses, and I'm going to guess that's an angle between between 0 and -90 degrees. I'm going to guess -70 degrees. I don't know. -41. Okay, that's where right, because it's in the fourth quadrant. You have to go down to get the fourth quadrant. So it's -41.9. How about this one? What am I going to get? Watch what happens. Come on, I thought I taught you guys this.
Isn't it an error?
Yes, if you try, because cosine, you can only plug in, you only get out values for cosine between -1 and 1. So you can only plug in values between -1 and 1 for the inverse function. How about tangent? Can I plug in 2,756?
Yes.
And I will probably get a number close to pi over 2, because that's when you're getting close to the asymptotes. Let's just see. Second tangent of 2,756. I bet I'm going to get an answer really close to 90 degrees. Okay? See that? Because that means that the ratio of the opposite side to the adjacent side is really big, and that happens when you're almost at 90 degrees, right? You get it? Okay? So that's that. Your homework. Homework, if you go, it's on my Schoology, but this is for next time. Not that yet. Okay? So that's your homework. And that's about it. Okay? But I'm not letting you leave for 5 more minutes or 3 more minutes at least. So
3 minutes.
It's back. 9:07.
well, that's why I said 3 minutes. But if you guys make any noise going down there, I'm gonna yell at you because I'm gonna get yelled at as it is.
So you're just passing down the ladder.
What?
Passing down the ladder.
No. If you see one of the administrators, you tell them you're Mr. Pettit.
Why would we blame on him?
Rebet.
Why?
Say Rebet.
Because they love him because Mr. Paddock does nothing wrong. So they won't get mad at Mr. Paddock. Me, they'll get mad at because I'm always doing things I'm not supposed to do. Okay? But I'm not. No, I'm okay. Just so you know. Yes. Oh! I didn't. Oh, I just had that on recording, so now you guys can use that against me.
The court of law.
The court of law. Oh,